Okay, this video is for exponential functions in class practice for section 4.3. And some of this we've been doing for a while. And we want to make sure that we understand how to solve for these problems. So we're just going to, this is kind of a review for a lot of you. So let's kind of go through each one of them. It says the city of Calcville has been declining. So I know it's been going down in population for the last 50 years. Okay. And then it says in the year 2000, the population was 650,000 and declining at a rate of 0.75% per year. Now, there's a reason why I did this. I've got time is 0 for the year 2000. And it says percent per year, so I know it's exponential. Okay, they want us to give a formula. The reason why I'm doing this is because that's less than 1%. You still have to move your decimal places 2 places to the left. So when you do 1 minus r, it's going to be 1 minus 0.0075 or 0.9925. So you got to be careful with that because there's still a percent. You still have to divide it by 100 and move your decimal place over 2 decimal places. So after that, this is pretty normal for us. So I have the population. My initial value is 650,000. So this equation is in thousands since the year 2000. And this is going to be times 0.9925 to the t. So this population is in thousands. And this is in years since 2000. What is the predicted population in 2010? Well, that's easy. So now I have to show 2010 minus 2000. So we're actually going to plug a 10 into our equation. So when I do that, I got P equals 650.9925 raised to the 10th power. And when I do, this is what I get, 602.86 thousand people. And you can leave it just like this. You don't have to move your decimal place and actually show it to me using thousands. This is perfectly fine with me. And I'm using Christmas colors. Now they want us to estimate when the population is 550,000. So I'm estimating t. I want to know when that happens. Okay, so I want to know when that happens. So remember, you got to show me the equation. I put in the P spot 550 because I started at 650. I want to know how long it's going to take me to get to 550. And here's my equation. And I'm solving for t. Set it all up. Now put it in your graphing calculator. Okay. And so I'm going to set up the graph. And you need to show the graph every single time until we start doing logs. So this is my population. That's my time. This is in years. This is in thousands. It starts at 650 and it's decreasing. And you want to know when it gets to 550. So where does it cross? And when you do that, you get 22.19 years. So look at your table to see, okay, how is that going to work? Because you're going to have to go over enough to see where it crosses in the window. All right. And this sketch is perfectly fine. And that's how I want you to do that one. All right. The second one says, suppose Y, the number of cases of disease, is reduced by 10% each year. So again, I'm doing percent per year, so I know it's exponential and it's being reduced. So I know this is 1 minus R, so it's 1 minus 0.1. Oh, I'm going ahead a little bit. 1 minus 0.1, so it's going to be 0.9. So the number of diseases, so they didn't really tell us what to use, so I'm just going to use Y. So Y equals, the number of cases starts out with 10,000 cases, and it's decreasing 10%, so it's going to be 0.9 there, and I'm going to raise it to the x power. Okay? Oh, they said use t, so I'll use t. That's okay. I can use t. That's not, most of the time it is t for us. Then it says, how many cases will there be 5 years from now? So I'm going to plug in a 5, because they didn't really give us a year. And remember, this is decreasing, so the number should be less than 5,000, and it comes out to be this, 5,904.9, which is roughly 5,905 cases. You can go up or down, because cases are people, So I don't mind if you round up or down, just as long as you don't leave it like that, because we're talking about people, and that's kind of yuck if you have part of a person. All right. Then it says, how long does it take to reduce the number of cases to 1,000? So again, we're going to put the 1,000 over here, equals 10,000, 0.9 to the t. T equals, do your little sketch over here. This is time in years. This is cases in thousands. It's going to start at 10,000 and it's going to decrease. And I want to know when there's 1,000. This is the graph that you show. And when I put it in my calculator, I get 21.85 years. So hopefully this in-class practice is a little bit of a review for you, because we've been doing this a lot, and I just wanted to make sure that you had the video for it.